This is Josh White with JW Math Tutoring, and today's video is going to focus on the October 2021 SAT QAS Math Section 3, the no calculator portion of the test. So just as a reminder, as I say before all of these videos where I have full solutions and explanations to released SAT and ACT exams, I like to show as many methods as possible to solve these questions on these exams. So please be aware that there might be some questions where I show, 2 or 3 different ways that you could solve a problem, which means that my videos are going to be a bit lengthier than some of the other explanation or solution videos that you might find out there. So these videos are not going to be within the amount of time that you're allowed to complete these sections on the test. But instead, they're going to show you, multiple ways that you can do some of the problems and occasionally talk about other related topics as well. All right, so with that being said, let's go ahead and get started.
But life is a dream the calculus could never predict.
All right, so let's go ahead get started with the SAT QAS from October 2021. This is section 3, the no calculator section. So go ahead and just scroll down here. Start with problem number 1. This is just a basic linear equation, and it's pretty easy to simplify the left side. You just combine the two like terms, and you get 5k. And then, of course, we just divide by 5. K equals 1. Correct answer is letter B. You could, of course, also do this one by back solving, plugging in the answers, but it's so simple and so basic, you pretty much don't need to do that. All right, now for problem number 2, they give you an exponential function here, y equals 3 to the x, and they ask for the graph of it. Easiest way is to just start with a point or two, and then go down and look at your answer choices and see, does the graph go through that point? So I would just start with x equals 0, and when you plug that in, you get 3 to the 0, which you should know is just 1. So we're looking for the point 0, comma 1. So far, if I look at answer choice A, I see that it does go through 0, 1, right here. So this one is a possible answer. B does not go through 0, 1, which is right there, so cross it out. C does not go through 0, 1, which is up here, cross it out. And D does not go through 0, 1, just like the others, cross it out. So therefore, it's going to be answer A, again, process of elimination, and you don't need to find any more points than that on this one. All right, moving on to the next page, we have problem number 3 here with a quadratic function. They give you several points that are on this function here in a table, and they want to know which one could be the graph of it. So, okay, let's take the first point right here, which if we write it in coordinate form would be just negative 1, comma 0, and we'll see which of the answer choices has that point on it. Very, very similar to the last problem we just looked at. So, A, does it look like it crosses through negative 1, 0? Yeah, possibly. Could be right here, so we'll keep it. B, it looks like it could cross through negative 1, 0, so we'll keep it. C does not cross through there, so eliminate it. D does not cross at possibly negative 1, 0, so eliminate it. Okay, so now we've got 2 choices left, and we want to look at this next point here, the 0, negative 4, because that's what's going to help distinguish A from B. So does A go through 0, negative 4? Yes, it looks like it right down here. So this is going to be the correct answer. If you look at B, you can clearly see B goes through some point 0, comma something where it's, I'll just put B here for it's a y-intercept, and it's a positive number. Okay, it's not a negative number, therefore it cannot be negative 4, so we can cross it out and eliminate it. All right, looking at the problem to the right of it, here we have a quadratic function with an unknown constant in it. And they basically give us one point on this function, f of 2 is 12. So that means when x is 2, y is equal to 12. So all I have to do is just plug in for each of those values, and then we'll just solve what we get for c. So 12 goes in for f of x, or essentially y, and then every time that we see an x, we're going to plug in a 2. And now we're just going to do order of operations to multiply this out. So 2 squared is just going to be 4. And now I'm just going to do 3 times 4 to get 12. 4 times 2 gives me 8. Now at this point, you can probably actually look at it and realize that for this equation to be true, C is going to have to equal 8, because if you plug in an 8 for C, that would cancel out with the 8 at the back, and then you would just have 12 equals 12, which is a true statement. But if you don't recognize that, that's fine. We'll just go ahead and solve the equation. 12 plus 8 is 20 minus C. Now subtract 20 on both sides, and we get negative 8 equals negative C. And now we'll just divide by negative 1, so we get C equals 8. So therefore, correct answer for this one is going to be letter A. Now below that, we have problem number 5. Here you're given a formula with 2 variables, but they basically give you one of the values to plug in. So 20 is going to get plugged in for x, because x represents the number of minutes running, and they tell us the person ran for 20 minutes. So this really turns into just 11.5 times 20 plus 3.5, y equals 265. Now, 11.5 times 20 is actually not that difficult to do. Just basically picture 11.5, multiply it by 2, and then move the decimal over one spot. So essentially what's going to happen is, think of this as like 115. It's going to turn into 230, or technically 11.5 would turn into 23. And then again, you would move the decimal over one spot because you're multiplying by 20, not just by 2. So this turns out to be 230. And then we still have the 3.5y. And of course, that's equal to 265. And then we subtract 230 on both sides, and that gives us 3.5y equal 235. And then we can go ahead and divide both sides by 3.5. And notice here your answer is just going to be 10. Okay? Because we have 35 over 3.5. It's basically, you notice how it's the same digits, it's just on the bottom. It's one, decimals moved over one spot. So the correct answer for this one is going to be letter D, 10. Moving on to the next page, there are actually 2 different ways you could solve this one at the top, number 6. So the actual way you simplify it is, you could take 6 over x and you could write it horizontally. It'd be divided by 18, and then you could do state change flip, which makes 6 over x, that stays. The division changes to multiplication, and then we flip the 18 into 1 over 18. And now you should hopefully see you can cancel out the 6 and the 18, and you're just left with a 3. So you get 1 over 3x. So the correct answer is going to be letter B. Now, just to show you, here's an alternate way that you could do this using picking numbers. So I'm going to choose a number for x of 6. And then if I plug that in, I get 6 over 6 all over 18. But you should be able to recognize 6 over 6 is just 1. So when I let x equal 6, this entire expression comes out to be equal to 1 over 18. Now go through your answer choices and plug in 6 for x and see which one equals 1 over 18. So A, 3 over 6. Is that 1 over 18? Nope. B, 1 over 3 times x. 1 over 3 times 6. Is that 1 over 18? Yep, matches. C, 108 over 6. Is that 1 over 18? No, the numerator's bigger. And D, 6 over 12. Is that equal to 1 over 18? No. So that's just an alternate method you could use. Again, picking numbers, where I picked a value for x, I plugged it in, I simplified the expression to a number, and then I plugged that value x into all the answer choices and saw which one equaled what I got when I simplified the expression. All right, problem below that, number 7, deals with some geometry. The correct answer to this problem is going to be letter C. And the reason is because whenever you have a line that is tangent, or line or line segment, either one, which is tangent to a circle, and that means that the line segment is just touching the circle in only one spot. It's not intersecting it more than once, but it's just touching at exactly one spot. So right here, point A is what we call the point of tangency. So when you have a line which is tangent to a circle and you draw a radius to that point of tangency, or a diameter, but in this case it's a radius, it always turns out that the radius you draw will be perpendicular to the tangent line. So in other words, this has to be a right angle. So BAC will be 90 degrees, this will be a right triangle, and the correct answer will be letter C always. Moving up now, top the page, problem number 8. Here they give us a graph and they want to know what's the value for x when f of x equals 0. So this is really no different than just asking where does the x-intercept of this function happen. Because when f of x equals 0, that means y equals 0, and that's the same criteria that an x-intercept is. An x-intercept is where the graph crosses the x-axis, i.e. its y-coordinate value is 0. So right here is going to be the point, and therefore it's going to be at the x value of 3. So number 8, the correct answer is just letter D. Below that, for number 9, we have a formula that you're asked to rearrange and solve for t. So there's multiple ways you could do this. I would recommend dividing by p first, although you don't have to do it that way. You could distribute, but dividing by p just makes it fewer steps. So you get a divided by p equal to rt plus 1. Then you can subtract 1 on both sides. You get a divided by p minus 1 equals rt. And then again, we're solving for t, so now I can just divide everything by r. So this whole thing would divide by r, or in other words, both terms would divide by r. And when you do it on the left, what's going to happen is the r is going to go in the denominator and be multiplied by the p. If you're not sure of that, it's basically the same kind of thing that happens in problem number 6 we just looked at, where when you do state change flip, like the 18, ended up flipping to the denominator. All right, so now when we look at the answer choices, let's see, we have a over, first we notice we have a minus 1 over r as one of the terms. So we can get rid of this. It doesn't have a 1 over r term. We can get rid of this. That doesn't have a 1 over r term. So now we're down to a and c. Obviously, it's going to be c because we need a divided by p times r. So the correct answer for this problem is going to be letter C. Moving on to the next page, we have problem number 10. The volume of this prism is just going to be found by multiplying the area of the base times the height of the prism. Now the height is technically this distance here of 10, and the base is this right triangle right here. So the capital B is really equal to the area of the right triangle, which is just going to be 1/2 base times height. So first let's find that. So it's going to be just 1/2 times 6 times 6, because we can multiply these two legs together. Just one is the base, one is the height, because they're perpendicular. So 6 times 6 is 36. Half of that is just 18. So that means the area of the base of this triangular prism is 18. And now we can just multiply that by the height, which is 10. So the total volume of this will be 180. And that's it. No more work is needed to be done. Correct answer is letter C. Now, moving down to the problem below it. Problem number 11 here. Okay, so we have 180 rooms. Half the rooms were cleaned. So we divide 180 in half. That means we have 90, we'll call them clean rooms. There were 9 housekeepers on duty. So 90 rooms, 9 housekeepers. That means 10 rooms, per housekeeper. And then here, they use R to represent the number of rooms that each housekeeper cleaned. So technically, R is going to equal 10. So now, all we have to do is just go through these answer choices and plug in 10 for R and see which equation is true, which equation makes sense. So in A, we have 9 times 10, which is 90. And then 2 times 90. Does that equal 180? Yes. So keep it for now. B, 9 times 10 is 90. 1/2 of 90, is that equal to 180? No. Half of 90 is 45. Cross it out. C, 10 plus 9 is 19. Is 2 times 19 equal to 180? Nope, cross it out. D, 10 plus 9 again is 19. Is half of 19 equal to 180? No, cross it out. So correct answer here is going to be letter A. Now, moving to the top of the right side of the page, problem number 12. This one, there are several different ways that you could do it. So the first approach that I'm going to take is I'm going to pick this point right here, which is on the graph. Okay? And so that means my x is 2, my y is 8. So again, I'm looking at the point 2, comma 8. So that means if I have two stones, that the total surface area is going to be 8 square feet, okay? Because y represents the area right here of the patio. So think about it. Each stone, again, is like k feet by k feet, all right? So if I have two stones, the area of the first one is k squared, just k times k. The area of the second one is k squared. So my total area would be k squared plus k squared, and that's equal to 8. All right? So now, if I just solve this basic equation, well, 2k squared, which is the total area from the two stones, has to equal 8. And now you could go ahead and just solve this out, and we find that k squared has to equal 4. In other words, the area of each stone is going to be 4, which just means that each side of these square stones is just going to be 2. So the correct answer for this one is going to be letter B, 2. Now, an alternate way you could do this, or it's just really it's just a different way to think about it, is you could go through the answer choices and you could work it out using that. Basically, it's back solving and seeing if the answer values you get match the line. So here's what I mean. Let's say k is 1, okay? So that means each stone is 1 by 1. So the area of one stone would just be 1 square unit. If I had two stones, then my total area would be 2 times 1, which would be 2 square units. Now, is 2, 2 on the graph? And the answer is no. 2, 2 would be like, basically right about here. 2 units to the right and 2 units up. So therefore, it's wrong. And then you could go through and like if you check the rest of them. So let's say you wanted to check 3 by 3, right? So the area of each stone would be 9. If I had two stones, my total area would be 18. 9 plus 9, 18. Is 2 18 on the graph? No, it's like way up here. It's too high. So that's wrong. And you could basically back solve it that way. Again, it's just a different way to think about it, but it's really using the same steps, the same operations for the first way that I demonstrated it. Okay, moving on now. Next page at the top, problem number 13. So this one, again, there are multiple ways you could do this one. I think honestly the easiest way is to first get the slope of this line. So if you start here, notice, and then right here, notice these are points that are right on grid marks. You don't have to estimate. You go down 2 and you go right 5. So that means the slope is going to be negative 2/5. So now we can look at each of these, and specifically, I'm going to remember the shortcut formula for when lines are in standard form. Negative a over b is the slope. And again, standard form is ax plus by equals c. So a is my coefficient or number in front of my x, b is my coefficient or number in front of my y. And so now I'm just going to take all these values and just plug them into this formula. So for a, it would be negative 5. It's positive 5, but there's the negative already in the formula over negative 2. Does that equal negative 2/5? Nope. Notice that b is going to have the same numbers, meaning a 5 on top and a 2 on the bottom, even though the sign is technically going to be switched. So now I can cross that out as well. So now we're down to c and d. And then c is going to be negative and then the positive 2 over negative 5 for b on the bottom. That simplifies to positive 2/5. That does not match, so therefore the correct answer is going to be letter D just by process of elimination, or it's just going to be negative 2 over positive 5. Alternate ways you could figure this out. You could notice that the y-intercept right here is the point 0, comma 2, or just 2, and the x-intercept over here is 5, comma 0, or just 5. And then you could go through the equations and you could like plug in just 0 for x or 0 for y and see which have the same corresponding intercepts. Okay, so that's just an alternate way that you could figure out the equation of this line as well. Below that, problem number 14, we have a system of equations. Okay, for a system of equations to have no solution, the multipliers on the x and y must be the same. So what I mean by that is whatever you multiply by to get from one equation to the other, it must be the same value for both x and y. And additionally, it must be different than whatever the multiplier is for the numbers on the right. So here, basically to get from 3 to negative 6, you multiply times negative 2. 3 times negative 2 is negative 6. So now you take n, you multiply it by negative 2, and that is equal to 12. So if I just put the negative 2 in front now, you can easily see that n must be negative 6. So the correct answer for this one is going to be letter B. Alternate way to do this too is technically figure out the slope of the bottom line, either by doing the negative a over b shortcut or putting it into slope-intercept form, and then basically figure out like what you can take the answer choices and plug them in and figure out which one of these will give the top line the same slope. Because when you have a system of equations and it's no solution, it means they have the same slope but different y-intercepts. So that's an alternate way to do this problem or to figure it out. Now at the top of the page, we have problem number 15. This is actually just a relatively basic square root to simplify. So hopefully you know that the square root of 16 is just going to be 4. Now so the C and D gone right away. For the power of the variable, the way that I tell students to figure out what the power is going to be when you simplify it is take the index of the radical, meaning that's the number that's out here. And since it's not written, it's technically equal to 2. Divide that index into the power of your variable. In other words, divide it into the exponent. The number of times it goes in, that's the outside exponent or the outside power. And then the remainder is how many of the variable are left inside. So for this one, 2 goes into 16 8 times. That means outside we're going to have a to the 8th power. The remainder is 0. That means there are no a's left inside. Okay, so the final answer for this one is just going to be letter B, 4a to the 8th. Now we start looking at the basically the grid-in problems. So starting with number 16, this is a very, very basic, simple problem because this line's already in slope-intercept form. So hopefully you recognize the slope is just going to be right here. Y equals mx plus b. M is just 3/5. So you could grid it in as 3 division sine 5, or you could also do a decimal sign and then a 6 after it. So either of those would be acceptable. For problem 17 now, here you have a system of equations and they want to know what one of the variables is. Notice since they ask for x, then what you want to do is you want to, if you're going to solve it using elimination, which is what I'd recommend, you want to eliminate y, because once you eliminate or cancel out all the y's, then you'll be left with the x's, and then you'll have your answer once you solve it. So I'm going to turn the two y's into positive 6 and negative 6. So the way I could do that is multiply everything on the top by 3 and on the denominator everything by 2. So the top equation becomes 9x plus 6y equals 24. The bottom equation becomes 8x minus 6y equals 10. Now we can add down the columns. These will cancel out because they're opposites. 17x equals 34. Divide by 17. X is just going to equal 2. So you would just grid in as the correct answer just the number 2. Okay, for problem number 18, this one is basically some trigonometry or also geometry. So first thing I would do is if you draw a right triangle here, okay, so let's just put whatever x here, we'll put y up here, we'll put z here. Okay, so we know sine of x, just if we write it out, it's opposite over hypotenuse. So here, the opposite side would be right here, which would be yz, and going to be over the hypotenuse, which would be, say, xy. Okay, so the sine of angle x is equal to this side over that side. Now, we also have an angle in this triangle that's 20 degrees, so I mean it has to go here by default. It's not x and it's not the right angle, so the only place left is up here, say at y. And we know the cosine of the 20-degree angle is basically going to equal to its adjacent side over the hypotenuse. So the adjacent side would be this, side here, yz, and then the hypotenuse is just going to be xy. So notice what happens here. These two expressions are equal. So therefore, the cosine of 20 is technically equal to the sine of x, and x down here just is going to have to be 70 degrees. So therefore, the correct answer to this problem is just the number 70. Obviously, you don't worry about shading in the degree sign, but you just put in 70, and that's it. At the top of the page now for problem number 19, this is an absolute value equation. So what we have to do is technically set up two different equations. The first one looks identical to the original problem, just no absolute value signs. The second one, we make the right side negative. So the positive 3 becomes negative 3. Then we solve each of these, and they're very easy to solve just by adding 2 to both sides. We get 5 for one answer, we get negative 1 for the other. And notice they want the sum of the solutions. So 5 plus negative 1 is just positive 4. So the correct answer for this one is 4. And you would just grid in that number. Now at the just the bottom of the page, below it, the last one on this section 3, no calculator section, we have problem number 20. So here, the sum of all the various solutions is equal to positive 5. So all we have to do is add up the various solutions to this equation. So if you set x squared equal to 0, because notice it's already factored, so we can just set each of the factors equal to 0. Okay, that gives us a solution of x equals 0. Technically, you square root both sides, and the square root of 0 is just 0. Okay, then we would set x plus 3 just equal to 0. We would subtract 3 on both sides, and we get x equals negative 3. And then the last one, if we technically solve it out, you would add b to both sides, and you would get x equals b. So the sum of these different solutions, 0 plus negative 3 plus b, is equal to 5. So negative 3 plus b equals 5. B is just going to equal 8. Add 3 to both sides. So all you're going to shade in or grid in is just the number 8. All right, so those are the solutions and explanations to the October 2021, SAT QAS from Section 3, the no calculator section. If you have any questions or comments or anything about the problems that were demonstrated on this test, feel free to leave them in the comments below. Otherwise, look out for the full solutions and explanations to the calculator section from the same test coming up shortly, to be posted a couple days after this video is posted. Otherwise, if you like this video, of course, please click the thumbs up on it, subscribe to my channel, and sign up for notifications as well. And see you with another math-related video shortly.